t-test, and by multi ANOVA, analyze of variance, standard deviations, normal distributions, all of all Harvard's testing, all of all are within inferential statistics. So tonight we should cover the main points of them, not all as we can. So we start in what is inferential statistics. Inferential statistics are used to test hypotheses about relationship between independent variable and dependent variable. The variables we have okay. What's inferential statistics? As you know, inferential statistics are mostly used for decision making statistics, testing for hypotheses or predictions or assumptions we are describing before our study, after our study have done or have tested. So we receive that our hypothesis accepted or rejected. So that mostly discussing the issue of independent variable and dependent variable, and allows to test your hypothesis. And when you are getting statistical significance, that means you are making decisions by inferential statistics, and you can say that it's unlike or it's significantly important or insignificantly important by using percentage of 5% errors, or the relationship between variables is due to chance. So classification in inferential statistics, it could be hypothesis testing or estimation based. In estimation based should be point estimation and interval estimation, like confidence interval. In hypothesis testing, we should try to explain how we should make formulation of our hypothesis, also setting up our level of significance, choosing our test, and decision making at the decision approach at the last station is decision making accepted or rejected. In formulation, we should try to describe and formulate how we should make null hypothesis and alternative hypothesis. In level of significance, we should take critical alpha or beta value we should take. And choosing test, we should make quantitative either or qualitative, and decision approach would be p-value or critical value, or and decision in the last station should be accepted or rejected. In statistical inference, and should be estimation of population value or testing hypothesis. In estimation, we should have point estimation like mean, proportion estimation, and range estimation should be confidence interval estimation. So what is, we go back to probability distribution. Probability distribution is how we can draw our probability data into a figure, as a figure or visualization method. Definition: probability distribution should be discrete number, fixed number, whole number, variable, and it's a table and should be presented as table or graph or formula or other device. We should specify all possible values of discrete random variable along with their respective probability. So we're using to explain how our data are distributed in a graphical method. So as whole number, not a discrete number. What's a random variable? When the value of variable should, like height or weight or age, can't be predictable in advance. And the variable, we should call it random variable. An example is adult height. When child is born, we cannot predict exactly his or her height at the maturity. Cumulative probability distribution, we should write fx. If showing probability that variable x is less than or equal to a certain value, we should write fx is equal probability of x greater than less than or equal to the x number. For example, this we have number of programs, we have frequency number, so we made probability x to f divided by n proportion like relative frequency. For example, if we have if you have 62 in a frequency, we should divide 297. We should get 0.2088. All like that. In fx, we should make like cumulative frequency, combination of adding up as long as frequency probability should go down, so that this number comes from this number we get by dividing. For example, we have 62 in frequency level divided by 297. Calculate it. Now you should receive 0.2088. Sorry, 0.2088. All other cells numbers in this column we should receive like that by changing only this variable. If it's this, we should change it 47, also 39, also 39, also 58, also 37, like that. We should divide 297, 4 divide 237, 11 divide 207. We should receive this number, like that. In this, we also call it cumulative relative frequency. Like that, if we have this number like 0.2088, they are same in this column, in these cells. So if we are going to down, we make adding up as long as we are going down. For example, 0.2088, we should add this number. After that, we should receive this number. 0.288 plus 0.1582, we should receive 0.3670. Like that, this number we should receive by adding this number to this number. We should receive this number. By all are like that, are same as the first two columns. What is binomial distribution? Binomial distribution, a model that number of success is a fixed number of independent trial where each individual has only two possible outcomes, either success or failure. Probability of success and probability of failure. And it's derived from process known as Bernoulli trade. Bernoulli trade is when random process or experiment, or we should call it trial, can result only two mutual exclusive outcome, either death or either alive, either sick or either well. This trial, we call it Bernoulli trial. The probability distribution of binomial random variable, for example x, the number of success is n independent trial, is like this formula. Fsx will be equal probability of x is equal to n divided by x, b power x, q power n minus x. So b stands for probability of success, q stands for probability of failure, n stands for total number, and x stands for frequency or sample number, where nx is in here, sorry. Nx stands for, sorry. It stands for number of combination in number of distinct objects taken for variable x of them at a time. For example, to understand binomial distribution, a specific medical treatment has known efficacy rate. A specific medical drug have known treatment of efficacy rate of 80%. So that 80% success, it means there is also 20% failure rate. If the doctor administered this treatment to a small group of 6 patients, what is the probability that exactly 4 patients will be successfully cured? First step is to identify variables in the given example. Like n number of treated, we have total number of 6, total number of patients treated. K, number of success. Number of success is 4, exact number of patients cured. B, probability of success 0.8, the cure rate per patient. 1 minus B stands for Q, or probability of failure is 0.20. The treatment failure rate is 1 minus 0.8 will equal to 0.20. The second step, calculate patient combination. Determine how many different combinations for 4 patients out of 6 can experience successful cure using combination formula. Like n divided by k is equal to n factor divided by k factor n minus k whole square by factor. For example, if we have 6 in total number and 4 in sample number equals to 6, 4, 6 minus 4. That means 15 different combinations of patients should recover. There are 15 different combinations of patients who could recover, who could receive treatment. The third step is compute component probability. Calculate independent probability of achieving 4 success to 2 failure. Cure probability component will be 0.8 power 4. Stands for 0.4096. Failure probability component stands for 1 minus B, or also we can call it Q. N minus K, power n minus K is to 0.20 power 2, stands 0.04. Step number 4, multiplication of all components. Multiplication of total patient combination by individual outcome probability to find result. Total combination was 15 times individually cure probability and failure probability. We have 0.4096, 0.04. Multiplication of all, we should receive that probability for 4 patients to be cured, drug tested, will be 0.24, 0.24576, as you see. As visually, you can see patient treatment distribution, total number 6, probability of success 0.8. Go to the horizontal row, which is number of patients cured. Vertical row, probability of success of drug. Probability of x should be equal in this column. That means 0.2457576. What is Bayesian distribution? Bayesian is a discrete probability distribution that models the number of times in independent variable event can occur within fixed interval time or within fixed space. Now we are going to calculate how event of independent variable can occur number of times by fixed place or fixed time, so that E probability x is equal k is equal E stands for symbol of constantly 2.718, while gamma is also called Lambert. It's a parameter of distribution or average number of occurrence of random event in interval or value. Continuous probability distribution. Continuous probability distribution model is like likelihood of outcome for random variable that can take any value within continuous, like weight, like height, like time. It has properties like area under the curve should equal 1. Probability of x is equal a is equal 0, where a is a constant. Area between 2 points A and B is a rank, so that we say probability would equal A less than X less than B. We use normal distribution to understand continuous distribution. Normal distribution, we can call it bell curves, is the famous distribution in statistics, perfectly symmetric round in its center, meaning that mean, median, and mode are all equal. I repeat it there. That means the mean or frequency in central tendency all are equal, like mean, median, and mode are all equal. Look at the picture. This is, we can call it normal distribution. Center will be 0. In left side, in right side we can say positive. In left side we can say negative. In right side it's number up to number 4. Like that up to number 4. Some of them uses a number 3. As you see. In the area we now highlighted is the area of probability. We can call it probability 0 is less than to x and x is less than 1.5. So the x is 0.043, so that is within it 0 up to 1.5. This is a continuous number. The normal distribution depends on 2 parameters. Parameter number 1 is mean populations on sigma. Mean population determines the location of the curve, as you see in picture, each indicating location of the curve by measuring their central tendency. But in sigma determines the scale of curve, how it peaks the curve, not how it distributed. While in population mean calculate how the distributed, how it's spread. But in sigma we are mostly focused on how our data is big. Like this, look this is explanation of center. So that this center is, we are using menu, like menu 1, 2, 3. While in sigma we are using their bigness, how they are high into the others. Now we have standard normal distribution, which is a normally scale if it's that we can say if our data is in normally distributed, it means we have -3 +3 between that, not less than -3, not greater than +3. In a special case, normal distribution with mean equal 0 and a standard deviation of 1. The equation of standard normal distribution is written as like that: minus infinite number is less than to z is less than to infinite positive. So that number should be positive and this number should be negative. In the left side, negative number. In right side, positive number. So that you will have this formula. This formula is a formula of normal distribution. The characteristic of standard normal distribution is symmetric about 0. The total area of the curve above the x is 1. we can use table in the appendix to find probability and areas. So now if we have normal distribution, we need to understand z-score. Go back to the formula. Z stands for z-score. X stands for sample. It stands for mean population. It stands for standard deviation. All, we can call it the formula of standard normal distribution. So that in z-score is a statistical method to determine if our sample mean is significantly differs from the known population mean. It relies on a standard deviation, standard normal distribution curve. If we have a standard normal distribution curve like this, we can now turn into our z-score. Look at this. This is numbers by percentage level. At the center, we have 34.13%. That means combination of them should be 68 and something. And the next green ones is 13.59. Also, the fourth one should be 2.14, and the last one is 0.18. Combine for them. At the section 1 is 68.28%. Section 2 is 95.2.4. Section 4, 99.72. So that if I say our z-score is 1 plus 1 minus, it means we have percentage of 68.28. If I say our z-score is plus 2 plus minus 2, I should write it. If I say our z-score equals plus and minus, so that we cannot write same sign, plus and minus 1, it stands for we have a standard deviation percentage reaching for 68.26. Something like that. If we say we have z-score of plus and minus 2, we have 95.4. If I say z-score, our z-score will equal plus and minus 3, that means we have 99.72. And also we can calculate less percentage that number by interacting this. If we need 90%, we go back, we say our z-score should be 1.96. This number, our z-score will equal plus and minus 1.96. That stands for 90%. A standard score or z-score. Z-score represents exactly the number of standard deviation as a value. X is from the mean. As you see, the formula z-score is equal is x observed value, x bar mean value, s standard deviation. For example, look at this. If we have sample 95 and standard sample mean of 100 and standard deviation of 10, calculate it. If we have sample 95 minus 100 mean divided by 10, that means minus 5 divided by 10 divided by minus 0.5. So minus 0.5, if we go to the score 0.5, that we have minus 0.5 at the section of 0.5, like this. We should get minus 0.5 by division of this number. It should enter in this level. Also, we need to explain what is confidence interval. Confidence interval is a range of value calculated from sample data that's likely to contain the true unknown parameter of entire population. It serves as indicator of estimated precision of uncertainty also we need to understand what is 95% confidence level actually mean. It means that if clinical researchers were to repeat the exact same study 100 times with 100 different random samples from same population, all of researchers should get 95 out of 100 calculated interval would successfully trap the true population. So we can say it, we have confidence level. If you have multiple time try, you should get 95% at that level. Like testing of blood pressure. If we are making 100 individuals for testing our tool that accurately measuring the blood pressure, so that if we continuously making for it, the system of the tool arrange it that 100% will be given you actual data of blood pressure, like that. Confidence interval should be starting from first range up to region to the last range, having point of estimate, middle size. Look at this, point of estimate is a single number, but interval we should get two range numbers, starting and ending. For example, imagine a pharmaceutical team tested a new drug designed to lower systolic pressure. They administered it into a sample of 500 patients. The point estimate that the sample's average drop in blood pressure is 12 millimeter mercury, and 95% confidence interval calculate range 9 millimeter mercury to 15 millimeter mercury. So that the point we have is 12 is the middle, while 95 has starting range to the ending range. Starting range is 9 millimeter mercury and ending range is 15 millimeter mercury. So that a confidence interval gives you accurately, in generally accurately, that your data will be set in there, not only specific for 12 millimeter mercury. It could be transformed into greater 15 or lesser 9, but in the middle should be 12. Look at this picture. As you see, we have confidence interval, lower bound to upper bound, and center mean. Center is 12 millimeter mercury, and the upper bound is 15, and lower bound is 9. Also, the sample estimation distribution is colored in all normal distribution level, and the color in the red is 95% confidence interval, and color in dots is point of estimation, while the absence color is not important in interval. Common levels of confidence interval. Confidence interval we should estimate as percentage probability, like between 1 to 0, like we can say 0.90, 0.95, 0.99 when we are speaking confidence interval level. We can say 1 minus A. A should be alpha level or significance level, which is how your confidence will have an error of an inconfidence. For example, if I say 95 have confidence, that means 100% missing for me is 5% error. That 5% error, after dividing 100, we should receive 0.5 at the center. Look at this, 0.05, like that. If we have 90% confidence, that means we have 10% error. We can call it alpha level. If we have 95% confidence, we have 5% error. If we have 99% confidence, we have 0.1 error. In like way, If we have 10%, if you have 90%, go back to level of 90 in Z score should be 1.8, 1.645. In point of 95, the Z score should be 1.96. Point of 99, the Z score should be 2.5776. Each level is estimating comparison of confidence level, alpha level, Z score. Alpha and Z score mostly seems to be interconnected tool used to draw conclusion about the data, establishing threshold of proof and calculate margins of error. If alpha is threshold probability that you can use before analyzing data, while Z acts as standard scale to measure how far away the data point to set from the average. Look at this. In the center side, we have 95% confidence inside. In upper level, we have Z score plus 1.96 plus 1.96. That means combination in the center, we have 95% confidence. It stands for Z score, not region 2. It's so near to 2. Look at this. It's not region 2. It's so near to 2. That 1.96. That means only 4 cents absence from region 2. Okay, also we can go, what is hypothesis testing? What is hypothesis? Hypothesis is a precise perception testable statement claiming about the population parameter you are evaluating using sample data. That, for example, you can agree what is normally existing in your environment, or sometimes you can disagree what is existing in your environment. If I say, for example, in that chemical cannot transform, that cannot have side effect in that patient. That's my assumption. After testing, we can get accepted for my hypothesis, my assumptions, or sometimes we can reject my hypothesis. To conduct a statistical test, you must always establish two opposing hypotheses, which means negative side and accept negative side for existing environments, or accepting side for existing environment. For example, null hypothesis means we can say negatively, we can make negatively for existing situations we can see. Alternative, we can say another options we have. If I ask you, for example, in a box of candle, for example, if I ask you, if I ask you, a box of candle containing manufacturers drawn by 100 candle are in within the box. I start discussion. I'm saying that there is not 100 candle in the box. I'm using null hypothesis. I'm saying no existing that number in the box. Another person says that there is should be increasing their number region to urban, like 100 and something. Another person says that this number should be less to the expected number. So the two later, the two remaining mostly is speaking alternative method, while I'm standing for negative side that not existing in this number. As I think you understand very well. I will give you example, so that every hypothesis we should make steps and procedures to test our hypothesis. Step number 1 is state null and alternative hypothesis. Step number 2, selecting level of significance. Step number 3, identifying and testing our statistics. Step number 4, formulating our decision rule. Step number 5, taking sample and arriving our last or finalization decision, which is do not reject our null hypothesis, or reject our null hypothesis, or accept our alternative hypothesis. For example, this is a null hypothesis example, and this is alternative hypothesis example. Smoking cessation rate in nicotine batch group equals smoking cessation rate in placebo batch group. For example, this is another hypothesis. I'm saying the rate of cessation smoking for people is using nicotine, same with those cessation using same like cigarette like some cigarette like materials was using, so that both of them are same. For example, if I say to you that number of cigarette smoking cessation group, stopping group are same with the number of cafe drinking cessation group, alternative should be smoking cessation rate in nicotine batch group not equal either increase or decrease. You can sense for it. I repeat it. Smoking cessation rate in nicotine batch group will not equal, should be increase, or it could be a decrease. Smoking cessation rate in placebo batch group either two-tail, increase upper tail, or decrease lower tail. Smoking cessation rate in nicotine batch groups is higher than smoking cessation rate of placebo group batch, which is tail 1. So that our hypothesis should occur like 2x2 table in 4 ways: true, false, reject, accept. In a true and reject, we have one error. We can call it type 1 error or false positive. In rejection and falso, we have correct decision. In the side of true and accepted, we have correct decision. While in falso and accepted, we have type 2 error. We can call it false negative. So our decision should occur in 4 ways, not else. Either error of 1 and error of 2, and 2 correct. Correct decision and correct decision from rejection and false, and correct decision from true and accept. So that type 1 error, we should use alpha significance, which means false positive, which means rejection, we should reject our true null hypothesis. If we get type 2 error, we should use p-value false positive. We are accepting false hypothesis. So that if we discussing the percentage of alpha, I was discussing it should be 99 to 90, or we can say 0.1 up to 0.001, while we are using beta and error, we mostly go into beta power, p power, or beta power. In beta power, we should estimate 80% up to 90, or we should say 0.10 up to 0.20, as I think you understand it. What's p-value? In statistics, there are 2 ways to determine whether evidence is likely or unlikely given initial assumption. So that before the modern books, they were using critical value approach, but recently we are using p-value approach, but they are all same. What we mostly using in research, journal articles, and statistical software. Look at this the graph. 2 tail, we have positive side tail and negative side tail. In the red, in the not like color, we call critical value. Also, we can call significant level. In the lines or second tape, we can call it p-value. Also, both of them we can call it test statistics. What's p-value? Is data or not consistently with null hypothesis? The difference is said to be statistical significance. If we have our null hypothesis was not consistently accepted, we have accepted, we have determined to existence of difference, we said to be statistical significance. That means we have statistical significance for different of our null hypothesis. If data are consistency same with the null hypothesis, is said to be we accept, and also we say statistical insignificance. In B should equal or greater than 0.01. Equal or greater than 0.01. So that B should be between 0.05 up to 0.01 is the lower evidence against the null hypothesis, which is mostly our critical area. We can accept everything we are in that position in a statistical. If we have 0.05, 0.04, 0.03, 0.02, 0.0 sorry 0.04, 0.05, 0.06, up to 0.10 is a low evidence, while 0.01 greater than, less than or equal to B value, or less than with 0.05 moderate evidence, 0.001 up to less than or equal B probability or B value, sorry, and 0.01 strong evidence. That is our null hypothesis. B, if less than 0.01 is very strong evidence. So that go back to the our Z scores. I need to explain something truly. For example, if you have B value, that means 99%, that means the B value will be 0.01, while B value is equal to 95 will equal to 0.05. If B value is equal to 90, we should have 0.1. So this is a low and this is a moderate, and this is a very strong or strong evidence, acceptable, very strong evidence, as I think you understand. In this also, look at the pictures below. Interpreting B value, we have overwhelming high significance when we are in 0.01, strong evidence when we are 0.05, weak evidence when we are 0.10, also no evidence when we are greater than 10, like 0.20, 0.30 is no evidence. We are rejected for that. Look at this also. 95% we can say do not reject our hypothesis. Mostly we accept if our value is within this, we accept our null hypothesis H sub 0. That means null hypothesis. In this critical value. If we are out of this, we reject. If we are in of this, we accept. As I think, if we are out, we reject. Rejection would be 2.5 outside. This is our confidence limit, and this is a lower confidence limit, so that mostly estimation is within our central data of normal distribution. Normal distribution. Also, what is t-test? What is t-test? T-test or student test is umbrella term of any statistical test to determine if the difference between the means of two groups is statistically significant. Mostly focus on calculation of two mean, calculation of comparison of two group mean, not elsewhere. Mostly could be symbol way for determination of two group. Amber test compares two complete separate groups of subject, while Bayer test compares same group of subject but two different times, before and after same group but different time. Before drug treatment, after drug treatment. One sample t-test compares single group average to know or to target average population. Only calculation of single groups, no elsewhere. So t-test should be occurring in possibly unbiased t-test, biased t-test, and one sample t-test. Unbiased t-test simply one specific type of students t-test used when two groups being compared and completely independent of each other. Give an example. Comparing average height of students of a school A versus school B. Comparing weight loss of patient taking a new weight loss drug to the other groups of taking placebo drug. Placebo means non-effective drug, like water for injection. Water for injection. That means we know that water for injection cannot transform any effect or any side effect to the patient. Also, what's ANOVA? ANOVA is analysis of variance and a statistical test used to compare average value more than 3 or more groups simultaneously, so that it's more powerful than t-test. While t-test is limited to compare just two groups, while ANOVA determines if at least one group average is significantly different from other groups. The core concept that ANOVA works is splitting two total variance, splitting of data in two parts, like between two groups and within group variance, how much the group average differs from each group. Also within group, how much individual score split inside each specific group. The test statistically, we use F-test statistics, which is a variance between the group is much larger than variance within the group, and F statistically with higher when the meaning that there's a statistical significance difference between them. Common tables of ANOVA. ANOVA could be one-way ANOVA comparing groups based on independent category variables. For example, comparing test score of students, test score for one exam of students who use 3 different studying methods. For example, ABL, textbook, or flashcard exam, so that we can determine difference between their 3 groups. In two-way ANOVA compares group based on 2 independent category variables. For example, comparing test scores based on studying method and grade level, like fishermen and seniors. Repeated measures of ANOVA used when the same subject are measured multiple times, again and again and again. Example, testing patient's blood pressure before treatment, and 1 month into treatment, and 6 months after treatment. So we are repeating our testing blood pressures to determine difference. Chi-square is statistics test that used to analyze category data by comparing actually observed result with the result you would theoretically expect, so that actually observed comparing to the expected data. So that if we are throwing corn, we are actually now corn could be only 2 options, like that. Unlike t-test and ANOVA, chi-square having this formula, compare 2 group average of continuous measurement like height and blood pressure, chi-square test and evaluate count or frequency how many items fall in a specific group of category. Thank you very much. As I think we are now completed or finished summary section 2 of biostatistics. I think only one section is remaining, and we shall cover in next week if Allah says. If you have any questions, you can discuss with me before closing our meeting. Thank you very much.